Hello and welcome back to Calculus 1 Saturday edition. We are going to talk about section 3.4 on product and quotient rule. So in a previous lecture, we have seen that if you have addition of two functions, subtraction of two functions, you can work derivatives out independently, and if you and then you can add and subtract those values going into the solution, right? So and the constant you can just copy. So we are going to now learn the product and quotient rules, and those are the two formulas that you memorize, and the product rule will be insanely important and used a lot later on in calculus and calculus 2 and 3 and differential equations. It's one of the rules that never goes away. Quotient rule can be replaced by product rule and chain rule and other stuff. It's convenient to know it, obviously, at all times. But the product rule is one of the main rules. The second most important rule, like after chain rule, product rule would be the second most important thing you learn in chapter 3. Well, tangent line is the most important in all of calculus 1, but anyway. So what is this product rule? I'm going to write this in a couple of different ways, and whatever way you remember, that's great. So the derivative of f of x times g of x. So if you have multiplication of two functions, it's going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. So this is the product rule. Now, a couple of more of these notations to help you out. The most famous one is with using u and v as functions f of x and g of x without writing the x part. So that's the most frequent one in use. But I'm going to also write f times g prime is fg prime plus gf prime. And if u equals f of x and v equals g of x in a substitution, we have the famous equation that is pretty much everywhere. uv prime plus vu prime. There we go. So most of the time you are going to run into product rule written this way, and I need you to understand that u and v are not variables. They are both functions, which is why I define them as functions, and u is just f of x and v is g of x, and then obviously u prime is the derivative of f and so on. The way I learned this when I was in Calc 1 is because I guess I am a visual learner. I said, see, this is what I call the first in my head, and this is what I call the second as a function. So I said copy the first derivative of the second plus copy the second derivative of the first, right? Whatever way you learn it. Probably there is a song out there for this stuff, and or you just write it 50 times like in good old days when your first assignment was to write this formula 50 times and the quotient formula 50 times. That's the first homework, and then you go into calculation. Whatever, just know the formula because you will use this a lot in your calculus education, which means all of the courses that use calculus will have it, including your engineering and physics and all of that stuff. Now, what is the way we use this formula? Well, we have remember that problem where you told me to FOIL, which was great. I'm going to actually find that problem and start with that as an example. The evil stuff, right? So let's start with this problem and just use the formula. So here is our example. So what I have here is my u and my v. My u prime in this case would be just 2, and the v prime would be 6x. I hope you agree that those are the parts of this. And now I just need to plug everything into the formula and simplify the answer, and I better get the same answer as in the first time when we did the problem. So copy the first, that's 2x plus 1, times the derivative of the second, which is 6x, plus copy the second, 3x squared plus 2, times the derivative of the first, and derivative of the first is 2 only. So that's great. So now you just need to do the algebra. You just need to do the algebra to make sure that this is the answer, the same answer as what we had before. So we distribute 6x, get 12x plus 6x, and then over here when we distribute 12x squared, and then plus another 6x squared plus 4, and the total of this is exactly the same what we had earlier as the result in the other one. So this is, I mean, this is not the proof that it works, right? This is us just showing that the formula, this is like verifying on one example, and there are infinitely many examples to go. So the product rule is this formula, and you are supposed to use it when you see the product. Now you might say, well, why would I do that when I can just simplify using algebra and not worry about memorizing formula? Well, you have to also consider stuff that you haven't seen, right? It is all nice and right, all fun and games when you have two polynomials multiplying each other, which you can FOIL and simplify. But what if you had the derivative of, e to the x times 4x squared plus 6x minus 1? Like, what now? Can you distribute e to the x now and simplify into a single polynomial to take the basic derivative? And the answer is clearly no, right? You cannot. So now you have your u to be e and v to be the polynomial, which means u prime is the same and v prime is 8x plus 6. And you have to use the formula to find the derivative. Now, I'm going to give you an example with stuff that you haven't seen yet. Well, actually, I can actually wait because it's going to be in the next lecture anyway. So I'm going to give you, 2 minutes, I guess, to work out the formula for product rule. So formula for product rule goes there, right, using the expressions, and then simplify it here to have the answer. So let's see what you get at the end. Okay, that should be plenty of time. And yeah, I think that's the answer on YouTube should be good. So we have copy the first, derivative of the second, which is 8x plus 6, plus copy the second, which is the whole 4x squared plus 6x minus 1 deal, times the derivative of the first, which is it stays e to the x. And now if you take a look at these two expressions, right, you see, can I simplify? And it's important to simplify because later on you will be using these expressions. You will be setting this equal to 0 to find roots and all of these kind of things. So the more you simplify, the better. So we factor out e to the x, that's common for both. And then just we have 4x squared, 8 plus is 14x, and then plus 5, which is what your friends on YouTube got. So that's that. Let's pick one from homework. And this particular problem, so this is problem 32. I would like you guys to solve this in two different ways. So there is a way where you use the algebra first, which means you simplify and then take the derivative, and the one where you take the product rule right away. So you're supposed to take the derivative of f of x is equal to 1 plus 1 over x squared, and then x squared plus 1. So, as I said, two ways. One way is algebra, then regular derivative. Algebra, regular derivative, and the other one is product rule. They both have to have the same answer, obviously, at the end. So let's see how far you get with this. All right, let's take a look at this problem together. We are going to use the algebra way as the blue way, and then we can do orange on the product rule, whatever, complementary colors, right? So way one, FOIL, which is algebra. So I have that f of x is going to be, when I multiply by 1, it gives me x squared plus 1. And then plus, when I multiply by 1 over x squared, I get 1 plus 1 over x squared. And that simplifies into x squared plus 2 plus 1 over x squared. And now I don't need the product rule to solve the problem. So I can just go f prime of x is 2x plus 0 plus negative 2 over x cubed for the derivative of this third one, right? Because you are taking the derivative of x to the negative 2. So negative 2 drops down, and then negative 2 minus 1 is negative 3. So that that gets us into over 3. And that's it. So we better get this answer using orange way 2, where we use the product rule immediately. So for this particular problem, we have the product rule applied. I'm going to say the derivative of, and then we have 1 plus x squared times 1 plus 1 over x squared. It doesn't matter in which order you write them. It's all commutative, right? Addition and this one is commutative. You can write them in any order you want. If you have division and subtraction, you have to be careful, but this one. So if I'm using a product rule, I'm going to real quick say that this is my u and this is my v. So my u prime is just 2x, and my v prime is going to be this negative 2 over x cubed, if you remember from right from before. So now I just unleash the formula. Copy the first times derivative of the second plus copy the second times derivative of the first. So this is your u, v prime, v, u prime. That's that. Now we have more algebra to do. It's going to be negative 2 over x cubed plus, now it's actually minus negative 2 over x plus 2x plus 2 over x. We have these two cancel, and we have 2x minus 2 over x cubed. Yep. Same answer. I mean, it has to be. Can't be anything else. It's just a formula. You are literally memorizing one formula for product rule, and you are using it. Now, in this case, you could have simplified, so clearly blue way was way faster than the orange way. Now that will come with practice, with experience, where you guys decide which method to use, right? So make sure you are using the correct method. Well, the last part of this lecture is the quotient rule. which is the rule for division. So now I have the derivative of f of x divided by g of x. So we have g of x squared, then you start with g of x, the derivative of f minus f derivative of g. The u form is u divided by v prime. You have a v squared, so vu prime minus uv prime. Which is what is usually. Again, being visual learner, I memorized that that's squared. Denominator just became squared, and I start with the same up there, and then there's just a minus instead of a plus, because it's obviously should be opposite of the product rule. So this rule now, we can use it to show the good old basic derivative. Remember when we said what is the derivative of 1 over x cubed? And we said, well, just use the basic power rule, where we said this is going to be x to the minus 3. You drop minus 3 down, and then x to the minus 4. You get negative 3 over x to the 4. So that was the problem using product rule. But now, sorry, using power rule, which was just from here to here was n x to the n minus 1. And now that we have the sledgehammer, you should not be using a sledgehammer to put the painting on a wall, but you can, right? So it's overkill to use the quotient rule on this, but you can, and we're going to get the same answer. It's more work, more mess. Obviously, you want to avoid quotient rule at all costs if you can help it, right? So you have your u, you have your v, and then you want your u prime, which is 0, and v prime, which is 3x squared. So you just put the formula together. You have your v squared. That's going to be x cubed squared. Then you start with x cubed. You multiply that by u prime, which is 0, minus, you copy u, which is 1, and then you have your v prime, which is 3x squared. So this is your v squared, this is your v, this is your u prime, this is your u, this is your v prime. We are literally plugging things into the formula. And now the first term, right, goes to 0. So all I have is negative 3x squared divided by x to the 6, which is negative 3 over x to the 4, which is the same answer we were looking for from before. So there is no reason to use this in that question, but there are many other questions where you absolutely need a quotient rule to help you through, because the functions are not compatible. So here's the 34, where you're supposed to take the derivative of, it's in terms of t, t to the 4/3 divided by e to the t. Since this is the derivative, we can go in line. I don't have to start a new one. So e to the t squared, copy e to the t, and then take the derivative of the top. So drops down the exponent, t, and then minus 1. Minus, copy the numerator, and derivative of the bottom is just e to the t. So now, you are done with the quotient rule. That's your quotient rule. The rest is algebra, making sure this is simplified as far as possible so that you can later on easily set it equal to 0, get critical points, and all the other stuff that we need to. So what I'm going to do is I'm going to factor out e to the t, leave in parentheses my 4/3 t to the 1/3 minus t to the 4/3, and then divide this by e to the t times e to the t, because that's what the squaring is, because one of these will cancel. And I can do better because I can also kick out t to the 1/3, which would leave me with 4/3 minus t divided by e to the t. So that maneuver is really useful, because once you realize that t to the 4/3 is t to the 3/3 times t to the 1/3. That's basic algebra, right? Because exponents would add, and then you see that there is 1/3 in common that you can kick out, and 3/3 is just 1. So this is your 3/3 term. Doing this is very useful, because if the next step is equal to 0 and an equation to solve, you are already there, because you know that this will produce 0, this will give you nothing, and then you also have a 4/3 as the answer. So 0 and 4/3 just by looking at it for later on in the course. Chapter 4 will ask you to set all of these to 0 and get the important things for the function. And here is one for you to practice. It says, oh, actually 54. Now be very careful here, right? F of z is given as z squared plus 1 divided by z, and you go, that's easy. Then I say times e to the z. So this is tricky, right? It's really tricky, this one. What does it have? Can you tell me? Anyone? What kind of rules? You guys fall asleep? Because it was too easy.
No, I'm still here.
It was too easy up to this problem, and now this problem drops. And okay, YouTube. Yeah.
Doesn't it have both rules, product
Yes.
and quotient?
Very good. Product and quotient. Now, in this particular problem, which is the main rule and which one is the sub rule? So, because you can't do both rules at the same time.
Would the main rule be product, because that's on both sides, and then the sub
Great.
just the quotient?
Yes. So this problem is a product rule. And then sub quotient.
You know who sponsors Ninja the most?
So The way we do this now is going to be, so you can say f prime of z is the product rule. So we have copy the first. Now the derivative of the second stays the same, plus copy the second. And now when I say derivative of the first, this is where the quotient goes. And that's going to be z squared z 2z minus z squared plus 1 times 1. So what you have here is u v prime plus v u prime, but the u prime was the quotient rule because, as you can see, u is the quotient. So we made it the first three terms without messing with the quotient at all, and then on the fourth one we had to because it was given as a rational function. So now we simplify this as much as we can. I'm going to still keep this until I simplify the quotient rule part, and then we'll factor out easy problem, easy. Not even close. But anyway, I have 2z squared minus z squared minus 1 divided by z squared. So we factor out e to the z. We're left with z squared plus 1 over z, plus over here we have z squared minus 1 over z squared. And we can multiply left one, to get the common denominator. So e to the z cubed plus z over z squared plus z squared minus 1 over z squared. Again, simplifying it for the sake of chapter 4. E to the z cubed plus z squared plus z minus 1 over z squared, which gives you e to the z over z squared, and you finally have your z cubed plus z squared plus z minus 1. And that would be the most simplified that you can, because now it's easy to set it equal to 0, right? And you see that the first one will give you no answers at all. The second one, right? Good luck with solving it, and problem is done. So that's what problems look like. And one thing that I neglected in a previous lecture, and I shouldn't have, is to ask you to find the tangent line. That's a TL. 4. And you have your f of x equals e to the x over x at x equals 1. Tangent line uses the derivative to find the slope. Tangent line question is in every section of chapter 3. Every section. So we have 10, 11 sections. Every section has a find the tangent line. Because in chapter 3 we learned the methods to find derivatives. And derivatives readily give us the tangent line. So it is appropriate to ask this particular question in every section of chapter 3. And it is the most important question of the entire Calc 1. So find a tangent line, you say, oh, well, I know what to do. For tangent line, all I need to do is to find the derivative, plug in 1, and I have my slope. And then I can go find b, and I am done. So that being said, slope of the tangent line is the derivative with a plugged in, and your a in this case is 1. This is something that you're going to need for every section of chapter 3, later on as well, but chapter 3 has all of those problems explicitly stated. So if I want to find the slope of the tangent line, clearly I have to find the derivative, and then I have to compute that derivative at the value that was given to us, which is in this case 1. So what's f prime of x? Oh, it's a quotient rule. Okay. X squared x e to the x minus e to the x times 1. So your uv situation is v squared. V u prime stays the same because it's e to the x. Then vanilla u, and then v prime in there. So the derivative simplifies when you kick out e to the x. You are left with x minus 1 over x squared. So it doesn't take too much work to see that the slope is 0, right? Because you are supposed to compute the derivative at 1, and that's going to give you e to the 1 times 1 minus 1 over 1 squared. Well, that's a 0. E to the 1 is e, and then e times 0 is 0, and then 0 divided by 1 is 0. So I have the slope. Y is going to be f at 1, and that's just e over 1, so just e. And now you have your x is 1, your y is e, and your slope is 0. So y equal mx plus b, y is e, m is 0, x is 1 plus b, so b is e, and you have your tangent line, y equals e. Why the 0 slope would kill whatever x you put there, so the tangent line is the horizontal line for this function. So the tangent line looks like this going through e. The function does something, whatever, but the tangent line is this. And let's say here, so function, whatever function does but it touches at 1. I know that. We can spend some more time to figure out what the actual function is. We don't care, right? We just know it's touching at 1. It has this tangent line because it's horizontal because the slope is 0. So it has to be, if you studied at all 3.2, you know that it has to be a min or a max at that value because it has a horizontal tangency. If you studied 3.2, you would know all of that stuff. But the tangent line problem is going to be a valid question for every single section of chapter 3. And I hope you will practice that the slope is the derivative computed at the point given to you, and then you go from there. Questions, concerns? Do you want more problems? Okay, if you have no questions, If you have no questions, let's then break for the day. I will be back at 1:30 for office hours, and exam will be posted as soon as I retype the whole thing. I have to retype it, unfortunately. So I will see you all. I mean, those of you joining at 1:30, the link is in announcements. So see you there.